Dear friends, welcome to another session on organic chemistry. Today, the subtopic is carboxylic acid. We are going to learn about the formula, general formula, and the reactions of carboxylic acid. The carboxylic acid is also known as the monocarboxylic acid or the fatty acid. Why monocarboxylic acid? Because it contains only one COOH group. The general formula for carboxylic acid is CnH2n plus 1 COOH, or it can be represented by RCOOH. The R stands for the alkyl group CnH2n plus 1. And the COH group stands for the carboxyl group. This is the functional group of the acid. The various members of carboxylic acid are methanoic acid, ethanoic acid, propanoic acid, butanoic acid, and so on. They form a series of saturated compounds which can be represented by the general formula CnH2n plus 1 COOH. Thus, it can be noted that methanoic acid, ethanoic acid, propanoic acid, butanoic acid, etc. are from the homologous series of carboxylic acid. The general formula for carboxylic acid is CnH2n plus 1 COOH. The formula of the first four members of carboxylic acid can be obtained by substituting the value of N appropriately. You should remember that for methanoic acid it should contain only one carbon atom. Since in the formula itself it has a CnH2n plus 1 COOH, the value of N turned out to be 0. Therefore, the formula of methanoic acid is HCOOH, where COOH is the functional group. Here you can see that the carbon has one bond with hydrogen atom. The same carbon is bonded with a double bond with oxygen atom, and the fourth bond is between the carbon and OH group. You should remember that the functional group of carboxylic acid is COOH, and in each and every carboxylic acid the COOH group must be present. In case for ethanoic acid, as in the formula itself there is COH, the value of N turns out to be 1 and it becomes CH3COH. The first carbon is attached to the second carbon by a single bond, and the first carbon has 3 hydrogen atoms attached to it by a single bond. And the second carbon atom contains one bond with the OH and 2 bonds with the oxygen atom. That is the functional group COOH. For propanoic acid, the value of N is 2. It becomes C2H5COH. The functional group, as said before, it is COOH. In propanoic acid, it has 3 carbon atoms. In between the first, second, and third carbon atoms, there is a single bond in between them. The first carbon contains 3 hydrogen atoms attached by a single bond. The second carbon atom is attached to 2 other hydrogen atom by single bond, and the third is the functional group. That is, the carbon is attached to an oxygen atom by a double bond, and the fourth bond between the carbon and the OH group. For butanic acid also, it is the same. Here, butanic acid should contain 4 carbon. Therefore, COH group contain 1 carbon, and the value of N turns out to be 3. It becomes C3H7COOH. The first carbon contains 3 hydrogen atoms with single bond. Second and third carbon contain 2 hydrogen atoms with single bond. In between the first, second, third, and fourth carbon, there is a single bond between the carbon-carbon atom. And the fourth carbon atom contains the carboxylic group. That is, carbon attached to oxygen with a double bond, and the fourth bond with a hydroxy group, that is OH group. The properties of carboxylic acid. These acids are weak monobasic acid. Why monobasic acid? Because they contain only 1 COOH group. The carboxylic acid reacts with alkalis to produce salt and water. For example, methanoic acid reacts with sodium hydroxide to form sodium methanoate and water. Another important property is that the carboxylic acid reacts with some metal like sodium to produce salt and hydrogen gas. Why some? It is because it is a weak acid. That's why it reacts with some reactive metals. Carboxylic acid react with metal to produce salt and hydrogen gas. For example, methanoic acid reacts with sodium to form sodium methanoate and hydrogen gas. Another important property of carboxylic acid is that the carboxylic acid reacts with metal carbonates. They react with metal carbonates to produce salt, water, and carbon dioxide. For example, methanoic acid reacts with sodium carbonate to produce sodium methanoate plus carbon dioxide and water. Carboxylic acid reacts with alcohol to produce ester and water. This type of reaction is known as esterification reaction, since they produce esters. Carboxylic acid reacts with alcohol in the presence of few drops of concentrated sulfuric acid used as catalyst to produce esters and water. It can be represented by a general equation where carboxylic acid has been represented by RCOH and alcohol with R-OH in red. Reacting in the presence of concentrated sulfuric acid as catalyst, it produces RCOOR- plus water. Actually, the OH group from the acid group and the H from the alcohol react together to form water. In case of methanoic acid reacting with ethanol, it reacts to produce ethyl methanoate. Ethyl from the ethanol group. Ethanoic acid react with methanol. Methanol is a alcohol group. It is a alkyl group. It is a methyl group. It turns out to be methyl ethanoate plus water. Therefore, the ethanoic acid in black reacting with the methanol in red, CH3OH in red, producing methyl ethanoate. And the OH group from the ethanoic acid react with the H group from the methanol to produce water. Another important reaction is the formation for the carboxylic acid. Ethanol react with potassium dichromate 6 to produce ethanoic acid and water. The ethanol is oxidized to carboxylic acid. That is, in case of ethanol, it is ethanoic acid. From carboxylic acid, esters can be manufactured. How to manufacture esters? Mix about 5 cm cube of ethanoic acid with 5 cm cube of ethanol in a boiling tube. To the mixture, carefully add about 1 cm cube of concentrated sulfuric acid. Then heat the mixture gently for about 10 minutes and leave the mixture to cool. Then pour the mixture into a beaker of water. You can see oily drops of a liquid which will float at the surface. This substance which is floating at the surface is ethyl ethanoate, that is an ester. As all esters, this liquid also will have a pleasant smell. Esters are being used widely in the society. Esters are used in the manufacture of perfumes, as food flavoring agents, and as solvent. We are now at the end of this present session. I hope by now you have learned about the formula of carboxylic acid, the formula of the various members of carboxylic acid, and their reaction. I hope to see you for our next session. Thank you. Until then, have a nice day.